Okay, so good afternoon, NG Vikings. Welcome to my session. Today, I'm going to talk about leveraging Angular in Node.js with Nest. To be more precise about how we can take advantage of Angular experience and Angular knowledge in a Node. Before diving into this topic, I'm going to quickly introduce myself. My name is Kamil. I'm a co-founder of Trillion.io, the next-level software consulting company, and I'm a full-stack software engineer primarily focused on the web-related things. I have also recently become a Google developer expert in Angular and web technologies. You can find me on Twitter using this highlighted red Twitter handle, and obviously on the GitHub. Beyond regular day-to-day work, I'm giving the value back to the community as an open source contributor. I'm the creator of NestJS, which is basically the fastest rising, the fastest growing framework for Node in 2018. And Nest is written entirely in TypeScript and is heavily inspired by Angular, hence it's a primary reason why I'm here today speaking in front of you. In the last year, we have noted almost 300% growth in the number of GitHub stars, leaving behind any other existing Node HTTP library, including all those famous ones like Express, Koa, Happy.js. Anyway, let's start with Angular. I suppose that everyone here is familiar with this excellent technology, and we love Angular. That's why we are here. When looking through the official documentation, we can find the following phrase. Angular is a platform. The question is, what does it mean? Generally, Angular provides a lot of things that come out of the box. We've got declarative templates, dependency injection, testing utilities, CLI, and so on, a lot of various useful stuff. Additionally, Angular combines best practices. It integrates them to solve development challenges. It's built on top of few well-known design patterns, which in turn properly applied to our software, simplifies the process of creating scalable, enterprise-grade systems. But most importantly, Angular gives right abstractions. These abstractions help us to organize our code and split features into logical units, like distribute building blocks in an efficient way. A huge part of these abstractions is not limited only to the front-end development, though. They also fit any other type of application, including server-side applications. And this is the moment when I would like to introduce NestJS to you. Before we move to this topic, I'm going to ask you a quick question. Who has heard about NestJS already? Please raise your hand. All right, it's amazing, like 60% of the audience. So thank you. As we know, TypeScript is a superset of JavaScript. Think of Nest as a superset of Node. It's a framework for building server-side applications in a very similar syntax as Angular. And thus, Nest, same as Angular, is a platform, but in terms of the backend development. Same as Angular, we are doing our best to empower developers and give them instruments to smoothly build progressive software. What we strive to deliver is a kind of higher level of reusability. When Node.js came up for the first time, it was considered as an outstanding revolution. Regardless of the whole event-driven architecture which is behind, Node was extraordinary because it allows us to use the same language as in the browser. You can basically take the code that runs in the browser and execute it locally as soon as it's platform independent, so there are no direct DOM references, window object, and so forth. And Nest is trying to raise this reusability on an even higher level. First of all, we talk about knowledge reusability. Nest is based on almost the same set of principles as Angular, and therefore you don't have to learn everything from scratch. Modularity, dependency injection, responsibility segregation, decorators, TypeScript as a language, all this is present in Nest as well. The second thing, experience reusability. Nest has practically identical API in many places. We believe that you have created many great applications in Angular, and it doesn't make sense to force you to learn new syntax, new API, new keywords, new language, right? Really waste your time. And therefore, Nest API is trying to stay as close as possible to corresponding Angular API. And the last thing, regardless of the whole developer experience, the very important point is code reusability. Let's talk about that. What can we share between backend and the frontend? The first thing, we can share DTOs, data transfer objects. So our frontend applications, like in 90% of cases, have to send some data through the network, and this data has some shape. This shape is actually a DTO. It can be described using a class or an interface. This interface may be called like create post DTO if you want to create a resource called post, or create user DTO, or maybe update user DTO, depending on what exactly we want to create. So let's have a look at the real code. This is an Angular service, and this Angular service has a create method inside. This create method is using HTTP client to perform HTTP request to our REST API using like this dependency with the name HTTP. What we are doing here, we are passing down the item, and the item type is create post DTO. So we are basically passing down the object that fulfills requirements of this either interface or a class. Now let's have a look at the server side. This is a controller defined in NestJS. This create actually represents a single endpoint, a post endpoint. So as you saw at the previous slide, here we are using post method. Here we are using post decorator to define an endpoint. And an input parameter to this method is a create post DTO. So same as at the Angular side, we are using the exact same class or interface, and we can share this code. What does it mean? We have an immediate experience. Every time when the backend team or a frontend team changes something, changes one property, add one property, change the type, or apply some transformations, validations, you, like the other side, like the frontend team, for example, will know about it immediately. You don't have to ask questions on Slack. You don't have to use that additional compilation step to use generators to transpile your class from Java to TypeScript. You are basically using the same language, and you can hold those classes in the same monorepo, and that's it. The second thing that we can share, interfaces. So our data has a shape. Like post may have an identifier, it may have a title, description, maybe an author. In this case, the same shape have to be sent through the network, and we need to represent it at both sides at once, right? At the server side and the front-end side. It doesn't make sense to really deduplicate this, this logic. So here we have this Angular method, which returns an observable, which is a result of HTTP request, observable which wraps post. Post, it might be this interface or a class with a few properties required to represent an actual entity. Similarly, at the Nest side, at the server side, we can have a method which actually returns the same interface or a class, right? It's using the exact same class or a file located in this monorepo in the library directory. And the last thing that we can share, services. Obviously, we can share validation services. We can share common logic for interceptors. We may have like a base interceptor, which then is extended from both platforms. Like Angular may have an Angular interceptor that extends from base interceptor, and also Nest may have a Nest interceptor, which extends from base interceptor. How can we do that? How can we share this code actually in a real-world example? The easiest solution would be to create a directory. Inside this directory, generate Angular application using Angular CLI, and eventually generate Nest application using Nest CLI. That was super simple. However, if you are looking for more sophisticated solutions and best practices according to the monorepo development, you can take advantage of Angular Console or Narwhal NX. Angular Console right now supports generating Node applications, which by default is a Nest application, so you can have a single Angular workspace, and inside a single Angular workspace, you may have multiple Angular applications and multiple Nest applications, and all of them can share code. All right, less theory, more examples, and raw knowledge. Let's have a look at the real frameworks API, compare them, see differences, see what's common. We are going to start from building blocks. At a higher level, modules are used to organize our code and split features into logical units. And every Nest application, as well as Angular application, has at least one module. And we may have like users module, products module, orders module, and so forth. Specifically, like this is the Angular module. Every module holds metadata properties. So it groups a few essential elements. For the sake of simplicity, I have omitted a couple of parameters like entry components here because it doesn't bring any relevant value. So the declarations property is a list of declarable classes, components, directives, pipes that belong to this module. Then we've got providers, right? Instruction to the dependency injection system on how to obtain a value for dependency. It might be a class, a factory, or a value. Another property, imports, a list of modules that should be folded into the module. And lastly, exports, a sort of public API of the module. You can explicitly define which declarations should be private and which should be publicly available for other modules. And now we are going to switch from Angular module into Nest module. We have to carry out several modifications. Let's start with declarations. In Nest, we don't have such thing as a view as a template. There are no HTML files, no visual representation that user may interact with because it's a server-side application. And therefore, we can get rid of declarations property. However, we still need entry points to our systems to somehow interact with it. In Nest, we are calling those entry points controllers. Basically, controllers are responsible for handling incoming requests and returning responses to clients. Providers remains the same. Again, class, value, factory, whatever. It works pretty much the same as in Angular. Then imports, again the same. It's a list of modules which should be folded into the module. And lastly, exports. And let's stop here for a moment. Why do we really need exports if we don't have declarations anymore? So the reason is that providers in Nest are private by default. They are encapsulated, isolated in the module. If we want to make them publicly available, visible, we have to explicitly export them and therefore make them a part of the public API. I'm talking about that because in Angular, providers are by default globally scoped, unless you register them in the lazy module, which is like the opposite behavior. All right, let's move to the code. This is a typical Angular module, class decorated with ng-module decorator, takes on metadata options object as a parameter. Since we would like to transform this module into the appropriate, corresponding Nest module, we need to perform a few small operations. At the beginning, we must change the decorator because the ng prefix is no longer required. Done. Nest is using module decorator to define the modules. We don't have any prefix. Secondly, declarations property. As I've mentioned already, declarations are useless. Instead, we need a way to define controllers, so we can quickly change declarations to controllers, and it's everything. This is Nest module. Quite similar, correct? So the second thing that I'm going to talk about, providers. As I've mentioned already, a provider is an instruction to the dependency injection system on how to obtain a value for dependency. And we have various types of providers, but for the sake of simplicity, I'm going to cover only one, like the most popular, common one, a class. Nest supports the rest of them as well, like factories, values, and even asynchronous factories. Anyway, let's dive into the code. So this is a typical Angular provider, a cut service with injectable decorator on top of it. HTTP service is a required dependency that will be eventually injected through constructor. Since Angular 6, we can register providers using the new provided in attribute. These providers are tree-shakeable, which means that they enable dead code elimination and lead to a smaller bundle. However, in server-side applications, we don't care about it that much because we don't have such a notion of a bundle. Obviously, we can bundle our code. We can produce a single executable file with Webpack, which is gonna actually, it may have some advantages. Like in a serverless environment, it's gonna affect your cold start and application will run faster. But mainly, it's like a difference between 1K or 2K, so it's not that important. And therefore, provided in is needless. And this is a Nest provider. As you can see, they are totally equivalent. Speaking about providers, we cannot skip the dependency injection part. Dependency injection is an important application design pattern. It helps making our application flexible, as well as testable and maintainable. Dependency injection system will take care of resolving all dependencies using TypeScript metadata, and therefore we don't have to manually create every instance by hand. We can also use inject decorator to explicitly indicate what should be injected in certain context. All this works exactly the same in Nest. We are also using TypeScript metadata to define relationships between classes. We also provide inject decorator, optional decorator, forward reference for handling circular dependencies. So you basically do not have to learn anything. The third element, guards. In Angular, guards control the router behavior. You can easily determine whether the navigation process should continue or not. And Angular provides us with a set of useful types of guards. So in order to allow user to proceed, navigate somewhere, every can activate guard would have to return true value. For example, authentication guard, permissions guard, and any other business-related guard. Let's switch to the server-side application now. User does not fit here, so we can remove it. Instead, we have a notion of a request. So we've got an incoming request to our application, and before this request may hit certain endpoint, every guard should check if this particular request should be allowed to proceed, like extract the request headers and validate the JSON Web Token, or maybe validate the API key, right? So let's compare real interfaces. As I said before, in Angular, we have a few different types of guards. They all serve different functionalities. This is the canActivate guard, so the class that implements canActivate interface. It has an injectable decorator, and this interface forces us to implement canActivate method, which in turn returns Boolean either synchronously or asynchronously. And the canActivate has a list of parameters, respectively activated root snapshot and router state snapshot. However, in server-side applications, we don't need both of them. Instead, we need something that supplies us with information about the incoming request. Hence, in Nest applications, we have execution context. So execution context contains request-specific information, and additionally, it also has execution context information. So you can use meta-programming abilities to build really reusable building blocks like guards that depends on some metadata, but it's an even bigger topic. All right, and the last element that I would like to cover today. In Angular, you declare interceptors that inspect and transform HTTP requests from your application to the server. The same interceptors may also inspect and transform the server responses on their way back to the application. So let's have a look at the diagram. Client application performs a request to the remote resource. The remote responds with an answer. And interceptors may enhance outgoing requests, as well as either intercept or transform incoming response from the server, right? So we have outgoing request and incoming response from the server. The flow is almost the same in server-side applications, even though we are on the opposite side of the diagram. Think about it like at the flip side of the coin. So the client application performs a request to our application, and we need to reply. We need to send our response. And interceptors may enhance incoming request, incoming, not outgoing in this case, as well as either intercept or transform outgoing response. So initially we have incoming response, right now we have outgoing response to the client. So we just went through a few essential Nest application elements. Well, it's still nothing, to be honest. There are so many things that Nest gives you out of the box. Firstly, pipes. We know pipes. A pipe takes in data as an input and transforms it to a desired output. Generally, you may notice that in your server-side application, you desire many of the same transformations repeatedly. For instance, the value that comes through the network has to be validated beforehand, right? We don't want to accept invalid DDOs. Also, some values have to be transformed to appropriate types. Maybe instead of interacting with literal JavaScript object deserialized JSON, we would like to have a real instance of our DTO, which may have some validation rules, maybe getters, setters, or even methods. Pipes in Nest are useful when it comes to such operations. We also have exception filters, called error handlers in Angular. Exception filters are useful to filter out exceptions, to attach your business-specific exception handling, allow interacting with the low-level API of either Express or Fastify. Very flexible mechanism. We also provide lots of integrations out of the box. We got integration with Mongoose in order to interact with your MongoDB, Mongo database. We have integration with TypeORM, if you are using other database like SQL database, Postgres, MySQL, but I'm gonna talk about Swagger. So we also have a Swagger module, which is gonna take your application and using the metadata provided by the TypeScript compiler, as well as provided by the Nest application, is gonna generate your whole open API specification out of the box. So you don't have to struggle with, you don't have to write it by hand on your own. It's gonna take your application and reflect every existing endpoint automatically. Additionally, the same applies to models. As soon as you are using correct, proper decorators to define properties and maybe apply some validation rules, it's gonna generate the whole specification out of the box. Additionally, we also have integrations for authentication here, as you can see on the animation. Another thing, WebSockets. Nest by default is using Socket.io to provide possibility, like capability to interact with WebSockets. However, Socket.io is kind of quite slow, so you can easily switch to any other WebSockets provider, even to native WebSockets. That's totally fine. And thanks to the huge abstraction layer that we have, you actually will not see the difference between those providers. So whether you are using Socket.io or native WebSockets, the only thing that you should be aware of is that what you have to do is to put subscribe message decorator on top of the method. Between parentheses, you have to pass the name of the event that you want to subscribe to, and that's it. Every time when Nest receives a message, in this case, events message, it's going to evaluate, execute, handle event method, and pass down the reference to a client, as well as the payload that was sent through the network. And inside the method, you can decide, do you want to respond to this event? Do you want to dispatch another event? Or maybe you want to ignore it entirely. The same applies to microservices. We support lots of message queues out of the box. We have an integration with RabbitMQ, with NATS, Redis, TCP. We also provide gRPC integration, and we plan to provide even more integrations in the future. You can also, if you want to, if it requires, like your organization wants to, let's say, use Google Cloud messaging, you can implement your own strategy, which only has to implement one single interface, and you can integrate it with Nest. And thanks to this abstraction layer that we provide, you basically will not see any difference in a final public API of the application. Let's do a small recap. In fact, it all boils down to reusability. In a few minutes, developer with Angular experience is able to start working with Nest with the understanding of the majority of the most relevant features. Knowledge of the API gives huge benefits and allows you to rapidly enter the world of server-side applications with a minimum effort. You basically do not have to learn almost anything related to the language, framework, and concepts used in this technology. But I haven't said everything yet. The developer workflow is also very important when working on a large product. And thus, we have created Nest CLI. And Nest CLI is heavily inspired by Angular as well. It's not that powerful yet, but exposes a few essential commands like nest new to generate your application, or nest generate to smoothly generate every existing building block, like a service, controller, module, pipe, or, for example, interceptor. And guess what? It's based on the excellent Angular dev kit schematics. Nest has a dedicated NestJS schematics package, which is used underneath by the CLI, by the Nest CLI. So you can easily create your own schematics inside your organizations if you want to. Also, they might be used together with Angular CLI. So if you, for some reason, do not want to use Nest CLI, you can use Angular CLI and bind NestJS schematics to this CLI, and that's fine. That's totally fine. Before the end of this talk, I would like to share a few latest announcements. First thing, we've been getting a lot of questions. How can I statically serve my existing Angular application or any other application through Nest? It has never been easier. What you have to do right now is you can basically call nest generate Angular application and pass the name of the application, which is in this case client, is gonna use external Angular schematics in order to generate your Angular application inside Nest applications. Additionally, it's gonna generate corresponding Angular module, which is actually Nest module imported by the Nest application, which is gonna serve your Angular application through Node app. What's the most important here is that this module is platform agnostic. So you can use Express, you can use Fastify, you can use whatever you want to. This module is going to work with all of them like a charm. And this is actually how the final API looks like. This is a Nest module, root module, which imports Angular module. It calls forRoot method in order to pass options objects so we can determine which path actually holds your Angular application, Angular bundle, and assets like images, fonts, and so forth. Another thing, Angular Universal. A normal Angular application executes in the browser, rendering pages in response to user actions. Angular Universal executes on the server, generating static application that later get bootstrapped on the client. This means that the application generally renders more quickly, giving our users like chance to view the application layout before it becomes fully interactive. With server-side rendering, we have better SEO. We can display the first page quickly, which can be critical for user engagement. We can improve performance, especially on mobile and low-powered devices. And again, it has never been easier. What you can do now is you can generate your Angular application using Angular CLI, and then you can navigate to this directory, and inside this directory, you can call ng@nestjs/ng-universal. What it's gonna do is gonna generate Nest application inside Angular application, and also it's gonna perform the whole heavy lifting underneath, so generate the full boilerplate code that you need in order to make your Angular application an Angular universal application. And additionally, it provides an extra compiler. This compiler allows you to perform to have live reloading of your server-side rendered application, which is super awesome. Let's just see it in an action. So basically, as you can see, I have changed a property in the application component, and what it's gonna do? It's gonna rebuild Angular application. It's also gonna rebuild server-side rendered Angular application and also API. So on the left side, you can see that we have a live reload. The browser is going to automatically refresh our website, and we have server-side rendered version of our Angular. So when I click on View Source to see what's inside, as you can see, it really performs server-side rendering on the fly. What are the advantages? Firstly, you can develop both client and server simultaneously at the same time, which is super awesome. If you don't want to live reload the browser on every API change, you can easily disable that using one single property. The second thing, you have live reload of server-side rendered application, Angular application, which was almost, maybe not impossible, but maybe not very popular so far. Lastly, I would like to say that Nest is open source, meaning that we are totally driven by the community. And therefore, I encourage everyone who shares similar ideas to join this little revolution. We would love for you to contribute to Nest and help make it even better than it's today. And there are a couple of companies and more than 100 people who decided to support us with their donations. A big thank you to all of them. Also, if you are looking for help with either Angular or Node or migration to NestJS, let us know, send us a message, let's talk. Thank you for your attention, thank you for having me.